Hello there, fifth graders. Welcome to your next math lesson. Today's math lesson is called Compare Fractions. So turn to the next available page in your math notebook and write the title of today's lesson at the top, Compare Fractions. Now, comparing fractions is easy when the denominators are the same. Like, let's say you had one boy named Dan had 3/4 of a pizza, and another boy named Steve had 1/4 of a pizza. Who has more pizza? Which is the bigger fraction? You can see that 3/4 is a bigger fraction because 3 takes up more of 4 than 1 takes up of 4. Or another way of saying it is 3 is a bigger portion of 4 than 1 is of 4. So 3/4 would be bigger. And we can draw a picture of this one so you can see what I'm talking about. 3/4 of a pizza looks like this. 3 out of the 4 slices. Whereas 1/4 of a pizza looks like this. 1 of the 4 slices. So you can easily see that this is more pizza. So 3/4 is a bigger fraction than 1/4. And the reason it's easy to see that 3/4 is bigger is because they have the same denominator. So it's easy to compare fractions when they have the same denominator, but it's harder to compare them when they have different denominators. Like, let's say we had to compare 3/4 to 7/8. Is 3/4 bigger? Is 7/8 bigger? Or are they equal? It's kind of hard to tell since they have different denominators. Now, in order to tell which fraction's bigger, we have to find the least common multiple for the two denominators, okay? So this is what we do. We list the 4 here and the 8 here, and we find the least common multiple for 4 and 8, the two denominators. So we count by 4s, 4, 8, and look, we've just gotten to what the second number is. So the first multiple of 8 is 8, and that's our LCM, our least common multiple. Just like yesterday's lesson when we were finding least common multiples, today we're using the least common multiple to compare fractions that have different denominators. And the way you use a least common multiple to compare fractions is by using the least common multiple as the least common denominator. So you use the LCM, least common multiple, as the LCD, least common denominator. So you change both denominators to have 8, the LCM, as the denominator. You change both fractions so that the LCM is now the LCD, the least common denominator. How do we do that? Well, we're going to make a fraction beside 3/4. It's going to have 8 as its denominator, but it's going to be an equivalent fraction to 3/4. And the way that we do that is we think, what would we have to multiply by 4 to get to 8? 4 times what equals 8? 4 times 2 equals 8. And then whatever you do to the bottom, you have to do to the top. So we multiplied 2 by the denominator, so we have to multiply 2 by the numerator as well. And 3 times 2 is 6. And now this fraction already has 8 as its denominator, so we don't have to change it. So now we're comparing 6/8 to 7/8. And since 6/8 is an equivalent fraction to 3/4, it means the same thing. It helps us compare 3/4 to 7/8. Now we can see that 3/4 is smaller than 7/8 because when we give 3/4 the same denominator that 7/8 has, it becomes 6/8. And 6 out of 8 is less than 7 out of 8. So 7/8 is bigger than 3/4. Let's do another one. We'll kind of box this off here to separate it from what we'll do next. Let's say we have to compare 2/3 to 7/10. these fractions are hard to compare. And again, what makes them hard to compare? It's the fact that they don't have the same denominator. So how do we make them have the same denominator? The first thing we do is we find the LCM, the least common multiple for 3 and 10. So we list 3 and 10 here, and we count by 3s and we count by 10s until we get the same number in both lists. So we're going to count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. We know we're not going to have to go higher than 30 because we know 30 is going to be a multiple of 10 because it ends in a 0, and all numbers that end in 0 are multiples of 10. So now we count by 10s, 10, 20, 30, and we've just found the LCM, the least common multiple for 3 and 10. It's 30. So now we're going to change both fractions to have a denominator of 30. And the way we do that is we're going to make equivalent fractions next to each of these fractions. They're both going to have a denominator of 30. This one is going to have a denominator of 30, but it's going to be an equivalent fraction to 2/3. This one is also going to have a denominator of 30, and it's going to be an equivalent fraction to 7/10. So we're going to be able to compare these two fractions with the same denominator. So then that's going to make them easy to compare. And the way we make these equivalent fractions to each of these fractions with 30 as a denominator is we think, what would we have to multiply by 3 to equal 30? What times 3 equals 30? Well, 10 times 3 equals 30. And then whatever you do to the bottom, you do to the top. We multiplied 10 times 3, so we have to multiply 10 times the 2 as well. And 2 times 10, we multiplied 10 by the denominator, so we also have to multiply 10 by the numerator. 2 times 10 is 20. So now we have 20 over 30, 20 30ths. And 20 30ths is an equivalent fraction to 2/3, but it has 30 as a denominator. Now we do the same thing over on this side. What times 10 equals 30? 10 times 3 equals 30. And whatever we do to the bottom, we have to do to the top. We multiplied 3 by the denominator. Now we have to multiply 3 by the numerator. Whoops. And 7 times 3 is 21. So now, instead of comparing 2/3 to 7/10, because they're hard to compare since they have different denominators, now we can compare 20 30ths to 21 30ths. And this helps us compare these fractions because 20 30ths is equivalent to 2/3, and 21 30ths is equivalent to 7/10. So which one's bigger? Well, 21 out of 30 is more than 20 out of 30, which means 7/10 is bigger. The alligator mouth always wants to eat the bigger fraction. So 7/10 is bigger, so we make the alligator mouth go towards 7/10. Okay? Let's box that off and work on our next example. Let's say we had 1/3 and we wanted to compare it to 5/9. We don't know which fraction is bigger. The way that we find out which fraction is bigger is we find the LCM, the least common multiple, for both denominators. So we list 3 and 9, and we count by 3s and we count by 9s until we get the same number in both lists. So we're going to count by 3s, 3, 6, 9. If you get the second number in your first list, you know you don't have to go any farther because 9 is the third multiple of 3, but it's going to be the first multiple for 9. So that means 9 is the LCM. And we use that LCM as a new denominator, as the least common denominator, the LCD, for both of our fractions. So we're going to make equivalent fractions next to each of these fractions, they're both going to have 9 as the denominator. And this one we actually don't even need to change. It already has 9 as the denominator. But we'll make the fraction anyways, just so you can see. So now we're making an equivalent fraction. It's going to have 9 as a denominator, and it's going to be equivalent to 1/3. And the way that we'll make sure it's equivalent to 1/3 is we'll multiply from the old denominator to the new denominator. What times 3 equals 9? 3 times 3 equals 9. And then whatever you do to the bottom, you have to do to the top. We multiplied 3 by the denominator, so now we have to multiply 3 by the numerator. And 1 times 3 equals 3. So since we multiplied the same number by the numerator and the denominator, we changed the numerator and the denominator by the same amount. So we've made an equivalent fraction. 3/9 means the same thing. It has the same value as 1/3, but it has the same denominator as 5/9 does. So it makes it easy to compare. And why don't we have to change this one? It already has 9 as a denominator. So if we try to think, what times 9 equals 9? It's 1. And then if we multiply that same thing by the numerator, 5 times 1 is 5. So if we try to change this fraction, it doesn't change at all because it already has 9 as its denominator. Now we're comparing 3/9 to 5/9. 5 out of 9 is bigger than 3 out of 9. So 5/9 is bigger than 3/9, which means 5/9 is bigger than 1/3, because 1/3 and 3/9 are equivalent fractions. So 5/9 is the bigger fraction. Let's do another example. I've noticed that kids need a lot of examples when it comes to finding common denominators. Let's do 1/4 and 1/6. Okay, you want to find out which fraction's bigger. The thing that makes these hard to compare is that they have different denominators. So we find the LCM for 4 and 6, the least common multiple. Okay, so that just means we count by 4s and we count by 6s until we get the same number in both lists. 4, 8, 12. Now, a lot of you can see that 12 is going to be a multiple of 6, because if you count by 6s, 12 is the second number. So now we count by 6s, 6, 12. We don't need to go any farther. 12 is the LCM. So now we're going to make two equivalent fractions next to our old fractions, but they're both going to have the least common multiple of 4 and 6. That's 12. They're both going to have 12 as their new denominator. 12 is now the LCD, the least common denominator. Okay, LCM and LCD really mean the same thing. It just becomes the LCD once you use the LCM as your new denominator. So now we multiply from our old denominators to our new one. And we think, what times 4 equals 12? Well, 4 times 3 equals 12. And whatever we do to the bottom, we have to do to the top. So we multiplied 3 times the denominator. Now we have to multiply 3 times the numerator. And 1 times 3 is 3. So 3/12 is an equivalent fraction to 1/4. It means the same thing. Now we do the same thing over here. What times 6 equals 12? 6 times 2 equals 12. Whatever you do to the bottom, you have to do to the top. We multiplied 2 times the denominator. Now we have to multiply 2 times the numerator. 1 times 2 is 2. Okay, now we can compare these fractions. It's hard to compare 1/4 to 1/6 because they don't have the same denominator, but it's easy to compare 3/12 to 2/12. 3 out of 12 is bigger than 2 out of 12. Therefore, 1/4 is bigger than 1/6. Okay, let's do another example together. Let's do 2/5. Let's compare 2/5 to 6/15. How do we compare these two fractions? All we have to do is find the LCM for both denominators. So we list the multiples of 5 and 15. That means we count by 5s and we count by 15s until we get a number that's in both lists. So we count by 5s, 5, 10, 15. And look, we just got the second number in our list of multiples of the first number, which means we don't have to go any farther because 15 is going to be the first multiple of 15. So that's our LCM, our least common multiple. And we're going to use it as our new denominator for 2/5 and 6/15. And notice 6/15 already has 15 as its denominator, so we don't actually have to change it. So we think, what times 5 equals 15? 5 times 3 equals 15. Okay? Whatever we do to the bottom, we have to do to the top. So we multiplied 3 by the denominator. Now we have to multiply 3 by the numerator. 2 times 3 is 6. And now we can do the same thing over here, even though it's not going to change anything. What times 15 equals 15? 1. Whatever we do to the bottom, we do to the top. 6 times 1 equals 6. See, it didn't change anything because we already had the least common multiple as the denominator on this side. So now we can see the fractions are equivalent. 2/5 is an equivalent fraction to 6/15. They have the same value because when we give them common denominators, they both have 6 as their numerator. So 6/15 is equivalent to 6/15, which means 2/5 is equivalent to 6/15 because when you give them both 15 as a denominator, they both have 6 as their numerator. So we put an equal sign there for that one. Let's do one more example together before I assign the independent work. Let's box all this off so we don't get confused. And let's compare 2/3 to 3/4. Which fraction's bigger? Well, the thing that makes them hard to compare is the fact that 2/3 and 3/4 have different denominators. This one has 3 as a denominator and this one has 4. So we list the multiples for 3 and 4 until we get a number that's in both lists. That's how we find the LCM, the least common multiple, for the two denominators, 3 and 4. So we count by 3s, 3, 6, 9, 12, and a lot of you can already tell 12 will be a multiple of 4. 4, 8, 12, and there's the LCM. It's 12. So now we're going to make two equivalent fractions. They're both going to have 12 as a denominator. This one is going to have 12 as a denominator, and it's going to be equivalent to 2/3. And this one is going to have 12 as a denominator, and it's going to be equivalent to 3/4. How do we make them equivalent? By doing to the top whatever we do to the bottom. So we multiply across from our old denominator to our new denominator. What times 3 equals 12? 3 times 4 equals 12. Whatever we do to the bottom, we have to do to the top. So we multiplied 4 times the denominator. Now we have to multiply 4 times the numerator. 2 times 4 is 8. So 8/12 is an equivalent fraction to 2/3. And we do the same thing over on this side. What times 4 equals 12? 4 times 3 equals 12. Whatever we do to the bottom, we have to do to the top. Since we multiplied 3 by the denominator, now we have to multiply 3 times the numerator. 3 times 3 equals 9. Now we can see which fraction's bigger because they have the same denominator. 8 out of 12, or 9 out of 12, or 9/12 is bigger than 8 out of 12, or 8/12, which means 3/4 is bigger than 2/3. Okay, now I'm going to assign your independent work. For your independent work, I'd like you to compare 1/5 and 3/15. Oops, 1/5 and 3/15. You're either going to write greater than, less than, or equal to between these two fractions. Make the alligator mouth eat the bigger fraction. Or if they're equivalent, put an equal sign between them. And I also want you to compare 1/6 and 1/3. Okay, write greater than, less than, or equal to between the two fractions. Make the alligator mouth eat the bigger fraction, or if they're equivalent, put an equal sign between them. Once you've done these two problems independently, click on the next video attached underneath this one to see if you did it correctly. I will see you there.